Physics Part 20. The spring balance and the lever balance. Spring balances are based on Hooke's law. See page. The extension of a loaded spring is proportional to the load. The extension is measured directly by a marker moving along a straight scale or by a point moving over a circular scale. As with any instrument using a scale or a pointer, you should take care for not introducing a parallax error when you take the readings. Position yourself that your line of the sight is perpendicular to the readings. You should position yourself so that the line of the sight is perpendicular to the scale. Before placing the object of unknown mass on the pan, check for zero error. There is likely to be a zero error adjustment screw on the balance. There is a figure of the spring balance, lever balance figure are based on the principle of moments. In common type, the unknown mass is placed on a pan, and balance is achieved by sliding a mass along a bar. Calibrated mass units until a bar is horizontal. This represents the condition in which the torque of the load is equal and opposite to the torque of the sliding mass and the bar. A reading is taken from the edge of the sliding mass on the division marked on the bar. In the case parallax error is less likely to be serious, again check for zero error before taking a reading. Another type of the lever balance. Well, we have got a lever balance here. We have got another lever balance with circular scale. So another type of lever balance has a pointer moving along a circular scale that is shown in the figure. The weight on the pointer arm is placed on one of the two positions in order to change the range, for example, from 0 to 100 gram to 0 to 1 kilogram. Both of these types of balance are used more for the convenience of obtaining a rapid approximate reading rather than for an accurate determination. An indication of the uncertainty involved in the readings with a particular balance can be obtained from the smallest division on the scale. There are examples. The mass of a quantity of a chemical is determined using a lever balance over the range of masses involved. The separation between the mass graduation on the bar is 2 gram. The mass of the empty container is 56 gram. And the mass of the container plus the chemical is 104 gram. Find the mass of the chemical and the uncertainty in this value. By subtraction, the mass of the chemical is 104 minus 56, which is equal to 48 grams. The uncertainty in each reading is likely to be the difference between the mass graduation on the beam, that is plus minus 2 gram. Each of the two readings has an uncertainty of plus minus 2 gram. The uncertainty in the mass of the chemical is thus plus minus 4 gram. Right, short term, the mass of the chemical used to make up a solution is determined as followed. A dish containing the chemical is placed on the pan of the spring balance. The pointer reading on the scale is shown in the figure. The chemical is then tipped into the known value of the water. The empty dish replaced on the pan giving the pointer reading shown in the figure 2.19b. What is the mass chemical and what is the uncertainty in this value? Choice of the method. As stated above, the top pan and spring balance are direct reading instruments. This means that the reading can be obtained quickly and conveniently. The lever balance requires adjustment and the sliding mass, but this takes only a very short time There may be some rules in your laboratory about which type of balance should be used for which task. In general, the pan of the balance should be kept clean and dry. Do not weigh out loose chemicals on the pan. Always use a container, the mass of which you have determined beforehand, or for which you have made allowances using the tare control